Hey guys, welcome to this video. Today we're going to cover recapping the SMD capacitors, or replacing the SMD capacitors on this Amiga CD32. This is not a comprehensive guide. I'm just a hobbyist. I'm not a professional. If you are a professional and watch this video and you see anything wrong with what I'm doing and what I'm saying, please feel free to post comments and educate all of us. That's how we learn. If you are interested in watching a comprehensive guide of a proven technique, I really recommend you watch Voultar's video of his PC Engine Turbo Duo full board recap. He also shows like how to clean corrosion. These boards are plagued with issues with capacitors, which is not the case of this particular board. This board is fairly clean, so I really recommend you watch this video. I'll put a link in the description. This particular video here is more about just showing my experience, the different things that I tried. I'm fairly new to this, so I still have changed my aim midway about certain techniques, and I'll go through that and the reasons why and the pros and the cons, and hopefully you can learn something from that process. But definitely this is not a how to, this is the right technique or anything like that. Anyway, I hope you enjoy it. Let's jump into it. The first thing I did with this board is start pre-tinning every single pad of each pad of the SMD capacitors that I was about to remove. As you may know, this is to just put a bit of fresh solder in there and help with melting the solder. Adding fresh solder potentially reduces the temperature needed to get a nice molten joint that you can then remove. So I did that for every single capacitor, and it took me about 8 minutes to do the entire board. I think there's about 30 caps. I don't think that step was mandatory. It probably would have worked without it, but I feel like it helped a lot, as you'll see after. I know that on Voultar's video with hot air, he's actually not pre-tinning the pads, he's just using the air. But when watching it, I felt that it was taking quite a bit of time with the air, and the longer you spend with the hot air on the board, you have to do some prep work to protect some other components. So he was actually protecting plastic connectors and other components with aluminum and kind of tape. So I wanted to avoid all of that and see if I could just do it a little bit quicker. Next step was to remove the caps themselves, and for this, this is the first time I use this technique, and I thought I'd use a soldering iron and hot air at the same time. I tried before using two soldering irons, kind of mimic the tweezers, the hot tweezers that are quite expensive, and I wanted to avoid buying that. That didn't work, the two soldering irons. It just was very awkward. But I found, as you can see here, this is not sped up, this is real time. I found that this technique was reasonably fast and not intrusive. I didn't damage any other pads. It came out fairly nice for no stress on the board. However, there's some caveats to it which I'll cover, but I found the best way is to first hit solder joint 1 with the iron, then hit solder joint 2 with the iron, and go on solder joint 1 with the hot air gun. That way the temperature is really kept high, and as you can see, it takes a few seconds to then push the capacitor out of the way. Now, I said that this technique is not perfect, and what happens is that, as you can see, sometimes the SMD cap just stays on the board. I push it out with the iron. I don't have a proper pair of tweezers. I push it out and it just quite hot. The capacitor itself, the metal casing, is quite hot. And what happened once for me is that the metal casing got on a SMD resistor, and it pushed it out of place, melting the solder on that SMD resistor and push it out of place. So it's a bit messy. If I had to do it again, I would try to move the capacitors out of the board directly and let them cool on my workbench, not on the board. The next step was to clean the excess solder off the pads, and I started using desoldering braid. And as you can see, the results are not exactly great. Plus, the soldering braid was getting very hot, so I used another roll of thinner braid to kind of let them cool. And you know, I wasn't happy with the results, so I just had a moment of, why am I doing this with braid when I have a desoldering gun? So I started using a desoldering gun. As you can see, the results are much cleaner. It's a lot faster. Obviously, not everybody has a desoldering gun. It's about $90 for a cheap US clone of a Hackle. But I really recommend it if you're gonna desolder stuff once in a while. It changed my life once I had one. From there, I just used some isopropyl alcohol and a toothbrush to clean all the flux and nastiness. Like I said earlier, there wasn't much dirt. The pads, as you can see here, trying to zoom in, they were fairly clean. Yeah, there was no corrosion, so that was an easy step. Now, I wanted to kind of have more visibility to my work. I didn't want to just replace all the caps without knowing what I'm doing, what value I'm adding here, if any. So in this case, I decided to test all the capacitors with an ESR meter. This is also cheap off eBay, about 15-20 USD. Really recommend it. Now, to measure the ESR value of a cap, we can use a charge like this. This is the best way I found so far. You can see that for our 22 microfarad capacitors at 35 volt, we should have a reading of 5.1 or less. Now, this is typical. And if you look online, you'll find different charts with different values. This was from a manual of a good ESR meter that a friend passed on to me, and I found that it was helpful. But when doing some research, this is not exact method of doing it. Each capacitor has a different ESR value. Even the brand, the value, I mean, depending on the exact model. So the only real way to do it, as far as I know, is to go into the datasheet of each single cap, find the datasheet, and find out what the ESR value should be. But in this case, it really helps finding dead or failing caps, and this is what we're trying to do here. So as you can see, initially I was trying to hook the pins with those little color hooks there, and I had a really hard time until I realized, hang on, again, you're doing it wrong. You have an adapter for this, so I tried to put in the chip holder there. That wasn't working either. That popped out, and then I found those pads, those exposed pads, where I could just hold the SMD cap in place and have my value. All the values were good, which in a way is bad news because it looks like I've done this whole recap for nothing, but you know, except for preventative measures, I guess. So all the caps tested well within the ESR value and the microfarad, and you know, everything looked good. So on to the recapping itself. The technique that has been shown in many videos. There's another video from EEVblog that shows how to solder SMD components that I'll link in the description as well. Is to, as you can see, I'm doing it here. You put solder on one pad only. You melt that pad, and with the solder melted, you place the component on. With caps, you can kind of, you know, hold them in your hands between your fingers, so it's not too hard. And then once the cap is in place, you release the soldering iron, let it cool down, and then you just solder the other side. So I've used that. I put some flux on before. I tried no clean, but it looked like it was evaporating very quickly. I don't know if my pen is old, my no clean pen is old, so I used proper you know, paste. And yeah, I did it all in about half an hour. 8 minutes to pre-tin all the pads. About 20 minutes to remove all the caps. Then 10 minutes-ish to remove all the excess solder and clean off with isopropyl. Then about half an hour to put them back. So an hour and 15 minutes roughly without testing the capacitor. So I remember doing my Turbo Duo and spending like more than half a day on it. So I think I've sped up the process a little bit. And I didn't rip any trace. I didn't do any damage except for that little resistor, but that's a lesson learned. So all in all, I think it was successful, and I hope you learned some things about it. Cheers.